Go back over the test review for test one because questions from that test will definitely be on this test. Test one is also available in the previous test section of Blackboard. I'll get that up tonight. A student provided pencil and calculator required to take the test. These will not be provided by the instructor. The size for the computers, and we might have to do that. The class is bigger than the number of computers we have. So last time we had a few people use their personal laptop. We'll probably should have them. Okay. Okay. ASCII code chart and number system chart will be provided. Tests will be provided in two parts, similar to the last one, except this time we'll do the written part here in class. These are the symbols you need to know. So there's going to be a lot of electrical symbols on here. Single pole, single throw switch, double throw switch, normally open, limit switch, normally close limit switch, normally close, held, open limit switch, normally open, held, close. Relay coils, normally open and normally closed, relay contacts, lights, normally open and normally closed, momentary contact. We okay on those? Why don't you know? Limit switches. Limit switch is normally open, non-activated. Limit switch normally open, held, closed. Limit switch normally closed, non-actuated. Right? Limit switch normally closed, held, open. Y'all see these? What else? Push buttons. They don't say. These are all over on the right-hand column. These are momentary contact push buttons. So that's what we have on operator panels. Most of them are not momentary contact, which is what? Yeah, remember? Momentary contact. It's only made or broke when you hold it down. When you let it go, it springs right back up. These are probably 90% of the buttons out there in the industry. But true buttons, they're momentary contact. We're going to a lot of what we call HMI panels, human machine interface panels, video panels, and what they do is they simulate normally open and normally closed. So the person that programs the panel has to stipulate when somebody touches that screen, it generates an alarm. Normally open, normally closed, and they're momentary contact. So you don't hardly ever see these out in. You need to see what? Push buttons, or what we call selector switches, that you have to grab and push. And the 1000s have selector switches. I think they're on our addresses 5, 6, 7, and 8. So the 1000s, they're utilizing all the inputs. I think it's got 5 push buttons and it's got 5 selectors. The push buttons go, they're normally open push buttons. So on that one, if you need a normally closed switch, you're going to have to use one of your selector switches and set it on. Set it on all of them. Okay? These, if you wanted to simulate that, you just normally close, you just turn the switch on all the time, right? And that's what you would do on the 1100s, the one that's mounted on the panel. By the way, we had one student when he was asking about the input. On the PLC, that's what they did. They put these down here. This is not the PLC. Where's the PLC? Right here. So when that lab was asking you about the PLC, it wasn't asking you about the switches that's available on this mount. We can mount all kind of trainers on this thing. These, in fact, if you take PLC 3, we'll take these PLCs off this thing and we're going to put the 1200s. So let's see the 1200s. I've got a Compact Logic over there that's mounted on one of these. These were really, really slick. We're trying to get more of these. Right? So this guy here's got 10 inputs, 0 through 9, and it's got 6 outputs, 0 through 5. We got one connected down. So you'll notice, by the way, this is set up by Allen Bradley goes in words. Siemens goes in bytes. So that's when you look at the switches. It goes 1, 0, 1, 2, 3, 4, 5, 6, 7. And it starts over 0, 1, 2, 3, 4, 5, 6, 7. So this was, we thought this was Siemens. So ours would go 0 to 7, and then the next two switches, 1, 0, and 7 on the next byte. Would be 8, 9 on the 1100. But we don't. It's no big deal. None of the labs that we do in this class is going to require over 8 inputs. None of them is going to require over 6 outputs. So what's not on there? The switches. Yeah. This is pretty important to know, guys. So even when you go down here to Lowe's and want to buy a switch, guess what they're going to be labeled? The number of poles, the number of throws. Anybody know what that is? So the number of poles is the number of switches that's controlled by the same operator. The number of throws is the positions that switch can be in and controls the circuit. Does that make sense? Charles, you should know that. Many classes as you've had. So this right here would be this would be a single pole, single throw. Because it only controls one circuit, right? We can turn it on or turn it off. This would be a single pole double throw. Makes sense? One switch controlled by the same operator. By the way, anybody know where we use these in housing? They call them, electricians call them three-way switches. These are where you can control the light. So the actual circuit is it's like like this, and your light bulb will be right here. I'm sorry. Huh? I'm doing this wrong. Let me write them up here first. So this would be a single pole, single throw, single pole, single throw. This would be a what? Single pole, double throw. What would this be? No. Yeah, I should have put this down. This would be a double pole, single throw. So we have two switches, but each switch only controls one circuit. Make sense? And then the dash means they're what? They're mechanically connected. They're controlled by the same operator. And this would be a what? Double pole, double throw. Now, a four-way switch is wired weird, but a three-way switch is nothing but a single pole, double throw. Relay contact normally open, relay contact normally closed. This says timers, which we'll get into later on. So okay, so that's everything's on there except for the about the switches, right? Know the meaning of the following terms: PLC program, bit, byte, word, long word, or double word, quad word, or double long word. PLCs, for some reason, don't call them what we learn them in digital. So digital and what we learn in computers. So a word is what? Everybody knows what a bit is, right? Mm-hmm. What is it? Mm-hmm. Single binary digit, right? Byte is what? The word is 16. A double word. The PLC is called long. For PLC that I was playing around with, I call it a long word. Then in computers, we learned it as a quad word. They call it what? Double long word. A BCD, everybody okay there? What's a code? Words used to represent something else. Yeah, so codes are used to represent something else, right? So ASCII is the American Standard Code for information entry. So we got these binary numbers that we use to represent the English alphabet or Latin alphabet. Then we got download. What does it mean, download in a PLC? Yeah, this is backwards from what you get used to. This is backwards from what you get to, and this is the problem we have because you're on the internet and you download and you upload all the time. Because they consider your computer to be the boss. In PLCs consider them to be the boss. Y'all understand? So when we download, we do what? We take our program in our computer and put it in the PLC. When we upload, we take it from the PLC and put it in our computer. And RS Logic does that automatically. Y'all probably didn't know that. So if you go in there and you log onto a computer, as soon as you connect, it pops up saying you want to create a new file. You hit create a new file. It uploads whatever's in the PLC. Some of y'all did that, where you made your program and you didn't download it. You hit online, and what did you get? You got the program that was in the thing, and your program was what? Yeah, so be careful. Gray code, that's the code. Scan, everybody okay on scan? Scan time. Scan time. Hit the end, right? We call that the scan time. How long it takes to scan your program from what? From the first run down to the end. And then what does it do? And by the way, you can look at, I think it's one of your status files, because it'll actually show you the scan time of the PLC while it's running. Normally closed, normally open. This is what we call push buttons. This is what we call our instructions, right? Examine if closed, examine if open. Everybody okay there? These are integers. Everybody okay with an integer is? What is an integer? Yeah, a number without a fraction. Floating point numbers. This is what we learned. Siemens calls them real numbers. And that's probably what you learned in math. For some reason, Alan Bradley calls it floating point numbers, which means that the decimal point has the ability to move anywhere in the number. 6 point. I use 6 point a lot when I'm doing grades. Because I want to round to 2 decimal points, so I'll tell it to always put my decimal point there. Cash registers use 6 point now. In syntax, what's syntax? It's not the language. So when you take English composition and you turn that into your structure, then they grade content, but they also grade syntax. What's syntax is the correct way of written, the language is written, right?
The way the language is written.
Right, so written is how correct the written language is. So when you turn your paper in, they start marking off because you didn't put a comma or you misspelled a word or you didn't use the right punctuation. What are they grading? They're grading syntax. That's what they're grading. So in PLCs, you're writing in a high-level language. It is very important when you're writing computer language. Your syntax has to be perfect, right? So ours is pretty easy because we've got that little box up there that we can click and tell us if we got any syntax errors, right? Yeah, the little thing with the little computer screen up there with the check mark, you can click on that. And because right off the bat, and why Artist Logic decided to do that, when you insert a rung, you already got a syntax error. And why is that? Because you don't have any inputs and you don't have any outputs. So every instruction is required to have an output. Now in our programs, we're going to require input. But when you take in advanced PLCs, when you get into like subroutines and stuff like that, a subroutine is an output instruction, but you don't have to put a what? You don't have to put an input. We have what we call unconditional subroutines, where they run every time it hits that instruction. And here though, you're going to have to require what? An input. Inputs, one or what? Or input. You got to have at least one output instruction in every run. The only output instructions we're using right now are what? We're using output instructions, bit instructions. OTE, right? Output. That's the only instructions we're using now. But when you get into timers, counters, what do you think counters are? They input or output? They're output. So they'll go on the right. Timers will be output. They'll go on the right. So we'll learn that besides these OTE instructions that we're dealing with right now, when we get into counters and timers, those are output instructions and they'll go on the right. To control the timer, you can put things on the left, right? On the L1 side. The first step, we need to know the steps here. The first step we configure the newly installed PLC is the configure the what? Communication channel between the programming device and the PLC. The first step in creating a new PLC program is to select the what? CPU, if it's a modular PLC. If it's a fixed PLC or a hybrid PLC, you select the model number. So it makes it a lot easier, right? You understand that? So if you got a modular PLC, you got to look at the CPU. You got to get the model, the actual, got to get the model number for the CPU itself. Then the last thing, depends on what you need to do, is the next thing we do, the same step is to configure the I/O devices to a modular PLC or a hybrid PLC with additional I/O modules. So this is the Siemens that we're going to do that you'll run into if you take the advanced PLC class. This is the little 1200 PLC that we're using, 1214. It's a nice PLC, and we being a Siemens certified training center, we get these for like $250, and it comes with everything. It comes with the software and everything. Oh. So this guy here has got, here's our inputs. And I don't know, you notice it goes in bytes. It goes from 0 to 7. And then the next byte starts at 0 to 5. Right? And then our outputs go from 0 to 7. And then 0 and 1 in the next byte. And then we have an analog card that's not part of the PLC. This is an analog output card. So if I don't have the analog card in there, I can come in, I can select the model number, I'm through. As soon as I plug that analog output card in there, what do I have to do? I have to go to this, I have to look at the model number or the part number on this, and I have to do the same thing that we do for that guy over there. It pops up a list, I select the model number, and I add that. This has also got an additional I/O model over here. So this gives us a 7, 0 through 7 and 0 through, so this gives us 11 additional inputs, and then we have 8 additional outputs that we've added on this. So as soon as I add this, what I got to do? I got to configure, I got to tell my program that I have this module on there, right? You understand? So more and more these little PLCs are, you can still get these big modular PLCs, but these are big guys. Now what we do, you'll see most often, you're going to see these tiny PLCs like this, and they're going to do what? On this guy here, we can add up to 8 modules on this thing. So you could put, this guy here could be a pretty powerful PLC, right? And then we mount them on this, it's called a DIN rail. This is pretty standard up there. You'll see a ton of these up there. You can buy relays that mount on these things. They just snap on, and then you can clip them off. You don't have to screw anything down. You just mount all these DIN rails up there, and you just snap everything in there. That's pretty neat. This guy here has a unique feature too, where the actual where we wire the inputs and outputs, you can get a screwdriver and snap this thing off. So what's nice about this is if you look at the 1100s that we have and the 1200s, if I had to replace the PLC, what would I have to do? I'd have to rewire that whole thing. On this one, if I had to replace the PLC, I could snap the terminal boards off, bring my new PLC in there with the programs in it, snap it in there, and snap these things in, I'd be ready to go. This is becoming very, very popular now. So even the Compact Logics that we have, which is the next version up, they have these removable terminal boards too. So it makes it a lot easier for the technician to swap out a PLC instead of having to rewire it. That used to be the problem with relays, is that we had to replace a relay, and it's got 15 contacts on it. What did we have to do? We had to rewire the whole thing. And that's where you got into problems. People would start wiring it and they'd do something and they wouldn't keep a document of what they did. So this is the Siemens 1200. So if you take, this is not a module, this is a network switch. So we can have the ability to hook up to 5 different PLCs on this one switch, or 4 PLCs, and then we could actually come in from a network. So we have 2 switches, so we could hook up all the PLCs on the line and make them communicate. So this guy here, since we added that other module on there, what does that mean we got to do? Well, we got to tell my application that I've done what? That I've added that module. So we configure, so on hybrid PLCs, if we add additional modules, then we're going to have to configure the I/O, right? That makes sense. And where do you do that on RS Logix? So where would we do that at? Right here where it says what? Yeah. And then this will bring up, this is for the 1100, by the way. The 1100s, you can put 4 additional modules on it. And then you come in here and find what? The model number of the module that you add. Yeah. This is also true. So Siemens added something on their Kia portal that's really, really slick. If you take that PLC free class, we'll show that. So you're okay on the project tree? Oh, this is the status register I was looking at. So right here on the, right here on your controller status, what does it show you if you go to right there? It shows you the actual scan time. Of course, the program's not running. I'm not online. I don't have a PLC out there right now. But this would do if we went online. This guy here would start updating, right? These are output files. This shows us our output, the actual output file bits, right? Everybody okay there? Somebody tried to change one of these the other day. You can't change these. So these are actually done with hardware, right? Okay. You can do what? Yeah, you can't force them. Another problem we're having too, guys, is that people come over here and they assign a symbol. And then they'll come up here and realize they used the wrong address, and they'll reassign the address and they try to give it the same symbol. So notice when I go down here and go to edit symbol and I try to give it first, it don't work. And why is that? Because the symbol's already been assigned. So if you assign an output a symbol and then you change the output, that symbol is still assigned to whatever you had before. So what you need to do down in your project tree, right down here, address and symbols, and there it is, right? So you can come up here and do what? Just double click on it. You can change it. You can type in a new symbol, or you can delete it, and it will let you enter the right symbol. But this has happened more than once in the lab in there. So I can delete it, and then I can come back, and then I should be able to assign this one first, right? Everybody okay there? This is also true in the Siemens PC. But what's also true is that another thing I don't know if you've noticed is that when you put an output device and you double click on it and you type in input, what does it show you down here? It shows you the next one that's available. And you can come down here and double click on that and it'll assign it that address. And that's also true on the Siemens too. Which is on the Siemens, when you start, I think it does it on this one, you start typing in a symbol name, you drop your symbols down, and you can pick it out of your symbol store. I think it does it here. The function of the remote. So what do we do when the PLC's in the remote mode? Now this is somebody's got theirs in the remote mode down there. I got to figure out how to do that. But these modular PLCs, we have 3 switches. We got what? Program, remote, and remote. So what if I got it in the remote? What does that mean? You switch it between the modes in your what? In your application. Right? Yeah. If you're on one of the 1000s or 1100s, it'll come up and say, it's in the remote mode. It's in the remote mode all the time. We could put it in the manual mode, and we'd have to go up on the touchpad and change the modes up there without a key. This is real popular on modular PLCs. And also the Compact Logics we have that are hybrid PLCs, they have this switch too. What's nice about that is that, what do you say? You switch it to run, and then what can you do? You take the key out. And then nobody else can come up there and put the computer up to it. But I told y'all all the
everybody.
Yeah. They can have to take it. So, yeah, all these disconnects, these are different ones, but all these disconnects up here have the same key. So we keep them on. So in the remote mode, it means we can switch it between running online with software, right? For the program mode, if you got, if that's available, what can you do in the program mode? You can download and upload programs, right? And then you switch to run mode, what does it do? It runs the program, right? Now your application, you have, online and offline, eh? Online and offline. What about offline? What can you do in offline? Create and edit programs, right? And then online, you're going to actually be online with a PLC, right? We're okay? So to download a program, you're going to have to switch. It's going to have to switch it to online or the monitors. You have to. I'm going to correct that. Then of course, upload is uploaded. You're going to do what? The dash lines between physical devices indicate they are mechanically connected and operate simultaneously. The rules for PLCs, not the ones that's in the book, the ones that I handed out. Base radix, the gray code, convert between BCD, binary. We're going to have to put that back on there, guys. Y'all are having all kind of problems with that. How to calculate the number of combinations we can use given the number of digits. How do you do that? X to the n, the base, the number of digits. The number of numerical combinations is x to the n minus 1. So that's the biggest number you can represent. The number of numerical combinations is x to the n. So I think on the last test it says how many numbers can we how many numerical combinations can we represent with 16 bits of binary to the 16? Look it up on your chart, right? 65,000, 536. So control instructions, what controls the run is between L1 and the load, right? You understand. And then our output instructions are going to be between L2 and the control device. Are you okay? I think the book teaches contacts, but the control devices are going to be contacts, but then we've got, when you get into PLC 2, we add input instructions saying if this is true, if this is true, then make the run would be true, right? If it's false. So some of your input instructions are not going to be contacts. Take PLC 2, you'll learn about all those other input instructions that we can put on the L1 side. Side for what? Contact. In this class, I will use contact. Which gets you a long way, guys. And the components of an RS logic input and output address. The L code there, you know that stuff. Y'all know what the input files are used for in the group, right? This is where we do the data file. Everybody know what the input data file is used for? What's that used for? It shows you when the input, is closed and the input is open. So the input is closed, you'll get a 1. If the input is open, you get a 2. The output data file, what's this shit? Well, if there's a 1 there, the output is turned on. If there's a 0 there, the output is what? Turned on. Status, this is where all your flags and stuff are at. Just looking at it. It keeps up your scan times in the status files, right? Did I show you all that? And later on, I'll show you this guy right here. This is really, really slick. And I wish I had my PLC hooked up. This is a free running clock right here. It's really, really cool. So we'll show y'all later on when we start using timers what we can do with that. It's really, really neat. If you have an error, this is where you'd come up, and this is where you'd see it, the error code. Unfortunately, Allen Bradley don't tell you what it is. Yeah, it does. So this is your status register right here. Are we okay? And this is your math register where you have, this is the status of the math. But we're not going to be doing any math this time. Right here where it says processor status, that's the actual status. These are system files. These are just what the processor uses itself. You can't get into these. You don't know what they're used for. These are data files. You don't know what they are. This is your status file right here. We got this status right here, and then we got this status right here. Oh, that's the same thing, isn't it? So the processor status up there, that's the one I clicked on. This one is exactly the same. So the S24 is a free running clock. That I'll show you how to use when we get into time. And then we got the B3 file. What's this for? Yeah, we can use it for other things, but right now we're going to use it for internal coil. And what's an internal coil? It's a control relay, but this is a coil whose contact. This is an output device, an OTE device that contacts never have to go outside, right? They don't need to generate an output. Timers, this is where we're going to keep up all the information on our timers. Counters, this is where we're going to keep all our information on our counters. Control register, we're not going to use that this semester at all. This is where we deal with real fancy instructions like rotate instructions and shift instructions. Are really, really, really cool. Integer, this is where all your integer numbers are kept, right? That makes sense. And then your floating point numbers, this is where we're not going to do any floating point math in this class. Your counters and your timers, those use integers. You can understand why a counter wouldn't count in half, right? It's integers. And timers, they use integers too, but what we can do is we'll show you how that works. So guys, I think it's, and then our logic, which we went over last class. You're going to have to identify those contacts, how they're wired. And how many logic functions did we go over? We went over 7, right? So all those, so we got AND, OR, NAND, NOR, NOT, exclusive OR, exclusive OR. And then you know the actual digital symbols of those that represent those. And then of course the truth table. All those are in your book, right? Or the PowerPoint. You know, if for some reason you didn't get down there and get your book, then where can you see all that stuff at? On the PowerPoints that's up on Blackboard. Okay guys, that's the test. That's what the test will be given at the end of class. Just like last time. So what we'll do is we'll come in here, just talk about some stuff, make sure we're okay, and we'll be in lab before the test, and then we'll take the test and get through early and do what. Are we okay? Any questions? Okay, y'all go ahead and take y'all break, and I'll meet y'all down at the lab.